Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so today we are going to have a brief discussion about valency. We have already made an introduction to this topic, but we have not said about this particular term. But if you see the previous video, if you have not seen, please do watch the previous video. It will be easier for you to understand this topic. So we have already discussed the formation of ions, isn't it? So as I have said, so today's topic is valency. Valency. Okay, fine. So as I have said, the noble gases are stable in nature, and if we inspect the electronic configuration of the noble gases, it shows that except helium, all the other noble gases have 8 electrons in their outermost shell. And other elements, the atoms of the other elements are reactive, as because it can be said that they do not have 8 electrons in their outermost shell. Now, in order to gain 8 electrons in the outermost shell, or in order to attain the electronic configuration of their nearest noble gas, the atoms of the elements other than noble gases, what do? They either leave some electrons, move some electrons, or they gain or accept some electrons, isn't it? And that is why we have seen that the atoms forms ions. Fine, okay. So what is the valency? Now you see, if we consider the sodium atom, the sodium atom has an atomic number of 11, configuration of 2, 8 and then 1. What it does to attain the configuration of the nearest noble gas, that is neon, it just simply expels this one extra electron in the last shell. Okay. Likewise, if you see chlorine has an atomic number of 17, so it has a configuration of 2, 8 and 7. So what does chlorine do? It actually accepts one electron in order to have the electronic configuration of the nearest noble gas, that is argon. Now, some atoms like sodium should have given away the one electron, and chlorine, on the other hand, non-metals like chlorine, they accept these electrons. Okay, so when this electron is accepted by this chlorine atom, what happens? The chlorine atom becomes negatively charged. Okay, so after this transformation, what happens? Chlorine atom becomes negatively charged. Okay, and the sodium atom becomes positively charged. So sodium atom becomes positively charged. How much positive? 1. So I will just write 1 plus sign here and 1 minus sign here. Now, so valency can be said to be the number of the electrons that is being given away, that is donated by the atoms, mainly the atoms of the metals, okay, or the number of electrons accepted by the atoms of the mainly non-metals, okay. Or there is also another way of attaining stable electronic configuration, and we have not discussed, but again today we will speak about that term, sharing of electrons. Okay, we will be discussing this term about the sharing of electrons. Okay, so the number of, so valency, how can we define valency? I am just writing it on the board. So valency can be defined as the number of electrons lost or gained or shared. 3 terms are there. You have already understood what it means to lose or gain electron. We have not discussed about the sharing. We will do it in later class. So number of electrons lost or gained or shared by the atom of an element. Atom of an element can be defined as the number of electrons lost or gained or shared by the atom of an element. Okay, so this is the valency of that particular element. Okay, rather you can also write this valency, or valency, regarding valency you can also say one thing, that valency is the combining capacity. Okay, so you must also note this term. So this is one aspect, and the other aspect is the combining capacity of an atom. How this is the combining capacity we will be discussing on the later classes. Combining capacity, okay, combining capacity of an atom, okay, remember this term. Fine. So this is valency. Now when the atom gains one electron, what charge does it have? It have a negative charge. So when it gains two electrons, it have two negative charge. So in that case we say the valency to be 2 minus. And if an atom say loses one electron or two electron, then what happens? It acquires some positive charge. How much positive charge? One positive charge or two positive charge. And that is when we say that the atom of that element has a valency of +1 or +2. Just giving two more examples. Okay, so I think you have written this. If not, please pause the video and do note it down. Okay, so say consider you have potassium atom. Potassium. Okay, potassium has an atomic number of 19. So it has a configuration of 2, then 8, then 8, then 1. So it basically what happens? It basically removes this one extra electron. So after removing the one extra electron, it has 19 protons, but instead of 19, it has now 18 electrons only. Then this potassium atom has a charge, positive charge, Xs1 positive charge, and hence it is written as K1 plus. So it has a valency of 1 plus. Likewise, if you consider say aluminum. Aluminum has an atomic number 13. It has a configuration of 2, 8, 3. 2, 8 and 3. So what happens? It denotes, it actually donates these 3 extra electrons in the outermost shell. Okay. After that, what happens to the aluminum atom? It becomes positively charged. How much positive charge it has? It has 3 extra positive charge. So now you can write Al 3 plus. So aluminum has a valency of 3 plus. Like this, we can get the valency of the different metallic atoms. There is a chart in your book which you have to memorize in order to understand these things in a better way. Okay. Okay, let me just give another example of two non-metals. Okay, so if I consider two non-metals, say consider oxygen. Okay, consider oxygen. So oxygen has an atomic number of 8. Okay, it has a configuration of 2, then 6, 2 and then 6. Okay, so what happens? This oxygen atom basically accepts 2 more electrons. Okay, it accepts 2 more electrons. So when it accepts 2 more electrons, now it has 10 electrons and 8 protons. So it has excess of negative charge. How much excess of negative charge? 2 excess negative charge. So we write it like this: O2 minus. Now this 2 minus is the valency of oxygen atom. Okay. Likewise, consider another non-metal. Say consider phosphorus. Okay. Phosphorus has an atomic number of say 15. Okay. So it has a configuration of, you must remember the atomic number of the at least first 20 elements, 2, 8 and then 5. What it does, it accepts 3 electrons in order to achieve the nearest electronic configuration of the nearest noble gas. 3 electrons it accepts. After accepting 3 electrons, it has 18 electrons and 15 protons. Hence it has 3 excess positive negative charge, and it is written as so P in 3 minus. Okay, fine. So in this way you can actually get the valency of various atoms of the various elements. Okay, now remember here one thing. We have discussed one term called radical. In one of the previous videos we have discussed the term radical. So what does radical mean? See this, when we have discussed these 4 examples, you see that there are individual atoms which are forming ions and they are having certain valency. Okay, now remember this thing. Sometimes what happens, not only one atom but rather a group of atoms combine to form as a single unit, and they have a certain positive or negative charge. Like I think like I can give one example. NH4. This 5 atoms, one atom of nitrogen and 4 atoms of hydrogen together forms a unit, and it has one excess positive charge on itself. So this is a positive radical. Okay, and it has a valency of 1 plus. Likewise, there are many other radicals like sulfate SO4. This is a complete unit, then it has a charge of 2 minus. So you have to remember this, the symbolic representation of the various radicals as well as the atoms and their corresponding valencies. Okay, this will be helpful in your due course With that, we will be ending our class today. In the next class, we will be discussing about bonding. Okay, till then, tata, goodbye. If you have any query, please do mention in the comment box. We will be happy to solve your problem. Thank you.